Now we're seeing our first views of the Ariane 5 on the launch pad. This is a live view of the Ariane 5 on the launch pad at Kourou, French Guiana. This television feed being provided by Arianespace and the European Space Agency, who will be providing their commentary of the launch beginning a short time from now. We'll be working in tandem with our colleagues down in Kourou throughout the course of the evening, and the first phase of the launch events that will culminate with the deployment of the Jules Verne's solar arrays about 1 hour and 36 minutes after launch. As we mentioned earlier, after years of work on the part of thousands of engineers over in Europe to test and validate all of the systems on the Jules Verne automated transfer vehicle, it is now poised for launch on its pad down in Kourou, French Guiana. The countdown throughout the course of the day today, as well as this evening, has gone by the book. No issues reported. A full load of updated software has been loaded into the onboard computers on the automated transfer vehicle. You're now once again looking at a view of the Ariane 5 on the launch pad where it is raining. However, there is no lightning reported in the area. A weather briefing that was completed a short time ago to the launch control team down in what is known as the Jupiter Control Center in Kourou, French Guiana, reported no problems and a green board for launch. We'll be standing by for further updates on the weather. The prime concern for an Ariane 5 would be any lightning in the area that could induce rocket-triggered lightning during the Ariane 5 climb to orbit. However, no lightning reported in the area, just some rain, as you can see on the lens of the television camera at the base of the Ariane 5 launch pad down in Kourou. The Ariane 5 stands 168 feet tall. It has a cryogenic main core. It was filled with liquid oxygen and liquid hydrogen over the past few hours and now stands poised for launch just 36 minutes from now. The payload within the fairing at the top is the large Jules Verne automated transfer vehicle. This video shows the processing and integrated testing of the automated transfer vehicle at what is known as the Erasmus Center in Europe. The solar array testing of the automated transfer vehicle took place about a year and a half or so ago. You can see the automated transfer vehicle in an acoustic chamber undergoing all of the testing of its systems. The automated transfer vehicle has 4 primary engines and 28 thrusters for on-orbit maneuvers. It will be the main engine of the upper stage of the Ariane 5 that will be fired twice, and we'll talk about that shortly after launch to provide the initial pulse for the automated transfer vehicle to reach its primary orbit. The solar array testing that you see here took place in July of 2006. The automated transfer vehicle ultimately, once it completed its solar array testing, and those solar arrays, by the way, span 72.8 feet in length. There are 4 of them, providing the automated transfer vehicle with the appearance of a giant insect in the configuration in which the arrays are mounted onto the integrated cargo carrier that you see here, the main body of the automated transfer vehicle, which was lowered onto a launch support structure for integrated testing over the course of the last year and a half. In a converted airplane hangar, the automated transfer vehicle then went through a series of rendezvous and docking tests so that the speed and a laser system comprised of lasers and two systems called videometers and telegoniometers could be tested, provided all of the data that the engineers required in order to be able to properly calibrate those lasers to determine for the onboard computers of the Jules Verne automated transfer vehicle the rate at which it needed to approach the aft docking port of the Zvezda service module and the rate at which it needed to close for a proper docking at a rate of about 1/10 of a meter per second, which is the normal docking speed that either the Russian Progress resupply ship or the ultimately the automated transfer vehicle will be docking to Zvezda at. So there's a glimpse of some of the early testing of the automated transfer vehicle that took place over the past year and a half that sets the stage for its launch about 33 minutes from now. Once again, just some rain falling at the launch site, but again, the word is no constraint to launch, at least at this time. There will be a subsequent weather briefing in about 20 minutes or so. Again, we'll be going down to Kourou, French Guiana, to pick up coverage in about 10 or 12 minutes from now as Arianespace provides the broadcast of the launch of the Ariane 5 and the lion's share of the commentary tonight, all the way through the deployment of the automated transfer vehicle's solar arrays 1 hour, 36 minutes after launch. Once the launch takes place, it will take about 9 minutes for the automated transfer vehicle to reach its preliminary orbit. The engine on the upper stage of the Ariane 5 will then fire for about 8 minutes to send the automated transfer vehicle into a highly elliptical orbit. That elliptical orbit will then enable the automated transfer vehicle to begin a 45-minute ballistic coast around to the other side of the Earth and over Australia at about 11:05 p.m. Central Time tonight. If all goes as planned, there will be a second burn of that upper stage for about 30 seconds to circularize the automated transfer vehicle's orbit, and then the ATV will be in its initial preliminary parking orbit, as you saw in that animation, at which point it will separate from the upper stage and begin all of its systems testings. The first critical milestone after that will be about 30 minutes after spacecraft separation, when the solar arrays are deployed, and the automated transfer vehicle will then begin a series of 4 weeks of testing. You can see in this view how the solar arrays do deploy. There are 4 of them, 72.8 feet in length, that provide the energy for the ATV systems. That is a navigational boom that will deploy several hours after the solar arrays deploy, and the automated transfer vehicle will be in its parking orbit. It will remain in a parking orbit about 1,200 statute miles away from the International Space Station for the next 4 weeks, at which point it will begin a series of maneuvers called demo days. Demo day 1 is scheduled for March 29th, and which time the automated transfer vehicle would begin to conduct an approach to the International Space Station, initially from a distance of about 24.2 statute miles, or 39 kilometers behind the station and 5 kilometers below the station, or about 3.1 statute miles below the station. It will move to a point just 2 miles away from the International Space Station to test all of its approach systems and then conduct what is called an escape maneuver. It will phase back around and 2 days later conduct a similar approach on what is known as Demo Day 2 on March 31st. At that point, through a series of maneuvers spanning several hours, the Jules Verne will close actually to within just 36 feet of the International Space Station. It will put on the brakes and hold. It will then do a retreat maneuver back to 62 feet, and then another escape burn to phase back around for the final docking 3 days later on April 3rd. These first two demo days, as they are known, demonstration day 1 and 2, are designed to test the automated escape capability of the automated transfer vehicle, which is fully automated. It involves very minimal crew interaction, unlike a Progress in which a crew can manually dock a Russian Progress cargo freighter to the International Space Station. The crew on board the station can only send commands to abort an approach for the automated transfer vehicle, and that will be tested on the second demonstration day by the crew on the station as they prepare for the ultimate arrival of the vehicle on April 3rd. At that time, on April 3rd, the Jules Verne will close in slowly but surely, first to a distance of 820 feet, then 62 feet, then 36 feet, and then move in the terminal phase of its final rendezvous for contact and capture. That docking on April 3rd is scheduled shortly after 9:30 Central Time on the morning of April 3rd. So a very intense period coming up for the engineers at the automated transfer vehicle, whose control center is in Toulouse, France, operated by the European Space Agency and the French space agency CNES. You see this view from a live view from the automated transfer vehicle's control center in Toulouse, where they continue to monitor the countdown that now is 27 minutes, 40 seconds away from the maiden launch of the Jules Verne automated transfer vehicle atop the mammoth Ariane 5 rocket from Kourou, French Guiana. Toulouse will take over control of all of the ATV's vehicle operations once the spacecraft is separated from the upper stage that will provide the first burn of 8 minutes to send the Jules Verne into an elliptical orbit, and then a second burn of 30 seconds that will circularize that orbit and send the ATV off into what is known as a parking or loitering orbit, a safe distance away from the International Space Station, about 1,200 miles away. Back here in the International Space Station Flight Control Room at the Johnson Space Center in Houston, we once again are standing by to join our colleagues down in Kourou, French Guiana, and the English-speaking broadcast courtesy of Arianespace that will provide all of the coverage of the launch itself and all of the critical activities. We have an animation that depicts what you will be seeing in terms of the launch once it gets underway. The Ariane 5, again, 168 feet tall, has a cryogenic main stage and twin solid rocket boosters. It will lift off from the launch pad in Kourou, complete a roll and pitch program, putting it on the proper azimuth of 51.6 degrees inclined to the equator. 2 minutes after launch, the solid rocket boosters separate, and the main Vulcan engine, as it is called, continues to burn to send the Ariane 5 toward orbit. Almost 4 minutes into the flight, the payload fairing that enshrouds the automated transfer vehicle will pyrotechnically separate. The Jules Verne will be exposed to the environment of space for the first time, And then the upper stage will separate. The first firing about 9 minutes after launch. An 8-minute burn will put the Jules Verne into an elliptical orbit. A second burn then will circularize the orbit, and the Jules Verne will be on its way for a 4-week testing program prior to its docking to the International Space Station. Again, the solar arrays will deploy about 30 minutes after spacecraft separation, about an hour and 36 minutes after launch, and then several hours later, a boom called a proximity boom, it's essentially a rendezvous antenna, will be deployed, and the ATV will be on its way. As it approaches the International Space Station, again, it uses a very sophisticated laser system to hone in on a series of retroreflectors on the aft end of the Zvezda service module that were installed during a series of Russian spacewalks by cosmonauts in previous expeditions to the International Space Station. This would be the scene in the final stages of rendezvous and docking on April 3rd, where the automated transfer vehicle would hone in on the docking target on the aft end of Zvezda and approach at a very glacial pace. The final contact and capture rate would be about 1/10 of a meter per second. Once the ATV has docked, a series of leak checks to make sure that there is a hard mate and a tight seal between the two vehicles would be conducted by Commander Peggy Whitson and her crew on board the station, which at that point on April 3rd would consist of Whitson, Yuri Malenchenko, and NASA astronaut Garrett Reisman, who will be launched to replace Leopold Aarts on the shuttle Endeavour, with that launch scheduled early Tuesday morning at 1:28 a.m. Central Time, 2:28 a.m. Eastern Time. We're now just inside 23 minutes before launch. We should be joining within the next couple of minutes our colleagues down in Kourou, French Guiana, at the launch site for live coverage of the terminal count. That will be complete with interviews and commentary that will carry us through the launch phase and through the critical maneuvers and all of the engine firings and solar array deployment an hour and 36 minutes after launch. Everything continues to go smoothly down in Kourou. No issues being reported. Some rain is falling at the launch site, but so far no weather violations that would prevent the launch. We'll be keeping a close eye, however, listening in as we join our team down in Kourou. The broadcast to be provided tonight, courtesy of Arianespace, which provides the launch services for the European Space Agency. We'll now go down to French Guiana, to Kourou, and the Arianespace launch site for live coverage of the maiden launch of the Jules Verne automated transfer vehicle. We'll be standing by here in Houston. This is Mission Control.
Greetings, everybody, wherever you may be, and welcome again to Kourou, the home of the Ariane family, for today's live broadcast of the launch of the ATV. A big launch, an historic one for Europe's space program and for humans in space. Ariane going for the record books tonight with the heaviest and the most complex payload in its history, the automated transfer vehicle, the cargo ship to serve the astronauts on the International Space Station.
Tonight, the English commentators are Joshua Jean-Paul and Alex Madembassy. And the French commentators are Thierry Bouvard and Franck Vasseur. You can follow our launch on our website, www.arianespace.com.
Everything A-OK here at the Space Base tonight. We're getting underway with the first launch of the year, and it is a big one, 20 tons. But it's a big launch in many ways. We're going to tell you all about all of them in just a moment. But first, we want to introduce Alex Madembassy, one of the program directors from Arianespace. Good evening.
Good evening, Josh. Good evening to everyone, and welcome to Kourou for this 181st Ariane flight and 37th Ariane 5 flight. Tonight's launch is the first of a kind, a new version of the Ariane 5, the dedicated ATV Ariane 5 ES.
You can see Ariane waiting on the pad tonight, and to the left, the green status panels telling the story that everything is fine, we're on time, and we're on target. We're going to be handling the commentary, Alex and I, for this historic launch for the next hour and 50 minutes or so. Lots coming up. To get us underway, over to Arianespace Chairman and Chief Executive Jean-Yves Le Gall for some opening words.
Bonsoir.
Good evening. This is the first launch of the year for Arianespace, and it's an extremely important one, since tonight we're going to deliver the ATV onto orbit. The ATV is important for Arianespace and important for the entire European space sector, and for three reasons. First, tonight's launch is a strategic one. The ATV program was decided by government decision at the Toulouse conference in 1995. 13 years later, after a very long process, we're going to launch it toward the International Space Station. Second, it's the first time that we're launching an Ariane 5 ES. The Ariane 5 ES version is like the Ariane 5 ECA, adapted and dedicated to the strategic governmental launches like the ATV tonight, and later on to other ATVs and to the Galileo constellation. The third reason this launch is important is that with it, the Guyana Space Center joins a very exclusive club, the space centers which allow access to the International Space Station. Till now, only Baikonur, with Soyuz and the Progress cargo vehicle, and Cape Canaveral with the shuttle, have made up this club. But from today, Kourou joins them with the ATV, and when the shuttle ceases service, there will be Baikonur and Kourou with the ATV. So, as you can see, tonight's launch is very important for all of us. Tonight's will be a new flight phase. After liftoff, we'll have the EPC flight for 10 minutes and the EPS flight as usual, but then a ballistic phase will follow, and then a second ignition of the EPS will occur while it's flying over the southern hemisphere. ATV separation will occur after 66 minutes. But all these events will be explained to you, and we shall, of course, keep you informed step by step of everything that's going on. I'll now let you watch this Ariane 5 ES launch of the ATV. The ATV bringing automatic docking system, which is a big milestone for space exploration. We'll be hearing much more about that. But the first part of the broadcast, we want to set the scene, focus on the major players tonight, making it all possible. This is the Arianespace Flight Directorate.
Major players, the Flight Directorate is composed of the Ariane authorities, including, of course, Mr. Le Gall and the Arianespace senior management, decision makers for delicate situations.
Any decisions, right, on any unforeseen events will be taken here. You'll see these gentlemen on the telephones with Evry and other places.
Mr. Michel Aymar. And here's Mr. Jean-Michel Desobeaux, the Ariane payload manager and program director for the ATV project.
And Alex, when you're not up here in the booth broadcasting, this is where you are usually sitting, right?
Absolutely.
You miss it?
Of course, I miss it a lot, especially tonight.
The ATV automated transfer vehicle, a new step for European space transportation, and another step for human space flight, a key tool.
And the new spaceship for the International Space Station tonight.
We're going to hear now from Jean-Jacques Dordain, the head of the European Space Agency, another major player, to find out about ESA's role in the ATV development.
The ATV is the heaviest and most complex vehicle ever developed at ESA. The heaviest because at liftoff it weighs over 20 tons and is carrying 9 tons of cargo. The most complex because at one and the same time it's a launcher stage, a satellite when it's in free flight, and a part of a manned infrastructure when it has docked. It is a unique vehicle allowing for automatic rendezvous with the ISS, of which, since the arrival of Columbus, ESA is now joint owner. To produce this complex vehicle, European space industry, led by EADS Astrium, has had to push back the frontiers of its expertise. It has been the result of cooperation of ESA's member states, but also with Russia, the United States, not forgetting CNES Kourou for the launch and CNES Toulouse for operations. At the outset, the ATV was of prime importance mainly to ESA, enabling us to pay our share of the common operating costs. Since then, however, it has evolved into a vital part of ISS activities and has thus become essential to all the partners. With the ATV, Europe is ideally placed for future exploration programs.
There's Mr. Dordain. He's one of the people keeping watch on the heaviest payload ever launched by Ariane. A big night for Europe's space program, and it's three key players, ESA, CNES, and Arianespace. Basically, they do more than this, but the resume, ESA funding new programs and construction of the base here, CNES overseeing coordination of the space-based operation, and Arianespace, of course, marketing and operating the launch services and the Ariane program.
Yes, the key actors of the European space program are all here tonight, and namely the European Space Agency, as you said, the CNES, Arianespace, and EADS Astrium. And it's worth saying that we're also very pleased and honored to welcome here tonight in Kourou the representatives of the US Space Agency, NASA, and the Russian aerospace company, Energia Rocket Corporation.
Next up, Yannick Descata, the president of CNES.
The
CNES has played an important role in the development of this extremely complex space system, the ATV. The qualification authority for the Ariane 5 ES launcher for this mission is the CNES Launcher Director. Ariane 5 has never before launched such a large payload. The CNES CSG, as the safety authority, has had to adapt its tracking station network for this mission. With a mobile station on board a vessel in the mid-Atlantic, a new station in the Azores, and others in New Zealand and Australia. At its Toulouse Space Center, the CNES has developed the ATV Control Center for the European Space Agency. It will receive the ATV telemetry from the space station, compute the maneuvers, and telecommand orders throughout the entire mission. These include orbital rendezvous and docking, plus the post-mission activities, undocking, and atmospheric re-entry. On re-entry, the ATV will burn up over the Pacific Ocean. CNES is indeed proud to have been involved in the development of what is without a doubt the European Space Agency's finest and most complex mission to date.
Mr. Yannick Descata, here on the screen, seems happy, as all of us, of course, tonight for this big event. And here the Thierry Vallée, our Director des Opérations, the DDO, the Range Operations Manager from CNES, who is in charge of supervising the readiness status of the launch-based systems and ground stations. And Philippe Roland, his counterpart on Arianespace side, is the Mission Director, and he is in charge of the operations of the ATV in interface with our customer ESA tonight.
These two often work together, the Arianespace Mission Director and the CNES CSG DDO. Green status panels on the left, continuing to tell the story. We're on time. We're doing well. Over to Jean-Michel Desaubos of Arianespace now for some facts and figures on the mission tonight.
This 181st Ariane flight involves many firsts. It's the first time Ariane carries such a heavy payload, 19.4 tons, and such a large payload, more than 10 meters high and more than 4.5 meter diameter. This is why we have to use the long 17 meters fairing. It's also the first time Ariane delivers its payload to a low Earth orbit, 260 kilometer altitude, and 51.62 degrees inclination. And tonight we have a launch on time, which means we have no launch window. We have to launch exactly at the time indicated here. And finally, the first time the Ariane reignites its EPS upper stage for an operational mission. This is a very specific Ariane 5 ES mission. Seeing all this first, you may imagine the enormous teamwork which has been necessary between all the teams involved, ESA, CNES, Arianespace, and the whole space industry in Europe, to reach such a novel milestone.
Coming up on 8 minutes before liftoff of the ATV, what's happening now on the launcher side?
The very last oxygen and hydrogen lifting cycles of the core stage continue to be performed. We are now in a waiting phase, a few minutes away from the start of the fully automatic checkout sequence called synchronized sequence.
You're going to hear the DDO call out at 7 minutes, the synchronized sequence, and we'll give you a little explanation of what that is. Before we do that, Jean-Michel, in his interview, talked about launching on time for the window tonight. What exactly is that?
Well, tonight we have no launch window. We have a rendezvous with the ISS, so we have a fixed launch time, and this will be the single moment that is fixed for the launch.
DDO going to call out the 7-minute mark, and we'll be into the final minutes of the final countdown where the computers are taking.
Attention pour H0 moins 7 minutes.
And DDO Thierry Vallée is going to call out that 7-minute mark, and then we'll be into the final moments of final countdown when the computers begin to take over.
Top H0 moins 7 minutes au début de la séquence finale lanceur.
Okay, we're beginning the final countdown where, what, 2 computers are checking out everything?
2 computers, redundant computers, so are checking and carrying out 2 sequences, one for the fluid system, the other one for the electrical systems.
And these computers are located up in the CDL, which is the launch
control center.
Launch center, which is a shot of it here. It's about 13, 14 kilometers to the northwest of where we are here in Jupiter. This man, André Sicard, who's the manager up there, you'll be hearing from him in a moment talking about the launcher campaign. But these are his teams of about 150, 200 men and women doing the final checks. They're much closer to the launch pad than we are.
Yeah, the launch operations manager is leading the Arianespace launch team together with the launch vehicle production manager. From this launch control center, the Arianespace and its industrial teams are permanently monitoring and operating all the ground and onboard fluid and electrical systems.
There's a shot of the fairing, the big 17-meter fairing, the large version, under which is the 20-ton automated transfer vehicle.
19.4, actually.
Close enough to 20.
Close enough to 20, yes. So the launcher is now fully fueled, and the upper stage and the attitude control system are ready to be operated for the launch.
At 5.5 minutes, Alex, can you give us, well, you give us a status report after the news, because we're going to go to the latest news from the Arianespace people, and there's quite a bit of news, as you'll see.
Big success for the Space Shuttle STS-122 mission. It has successfully delivered the European scientific module Columbus to the International Space Station. A module of 21 tons, 6.75 meters in length and 4.5 meters in diameter. It has been developed by Astrium in Bremen, and the European Space Agency has once again placed Europe as a long-term key player of space exploration.
International space conferences are where Arianespace often showcases new opportunities for its customers. Satellite 2008 in Washington, D.C., seen here, followed SatTech 2008 in Singapore, where Arianespace announced its new microsatellite carrying structure for Soyuz, which will allow the launch of 5 microsats weighing up to 400 kilos.
News from the Russians in French Guiana. The construction site of Soyuz is progressing well. In French Guiana, the infrastructures of the launch site have become a reality. This site is always very busy. In Europe, the Russian teams and the Arianespace teams are working together for the manufacturing of the first Soyuz launcher to be launched early next year.
The newest addition to the European launcher family, Vega, is growing with completion of the mobile gantry for its launch pad. The European Space Agency program, with Italy as prime contractor, is making steady progress, and Arianespace predicts a bright commercial future for the light-lift Vega vehicle.
ESA, CNES and Arianespace were honored by the presence of the French President Nicolas Sarkozy during his visit in French Guiana. To the key players of the space sector, Nicolas Sarkozy did reiterate France's dedication and involvement in the world space adventure.
A word about the weather before going on the air. We had a light cloud cover over here in Kourou, so my guess is we may lose the Ariane 5 to low clouds of visibility.
But so far the conditions are green and everything's fine. We do have constraints that are linked to the weather conditions at liftoff, especially the wind direction and velocity at low and high altitude, and mostly the risk of lightning due to a storm or the presence of important convective clouds. So we have a periodical forecast which is provided to the operational team up to 80 minus 1 minute.
Going to some shots of rollout, which took place yesterday. You can see the Ariane 5 coming out of the final assembly building, rolling out to the launch pad on a rail track.
This rollout was performed Friday morning, around 36 hours ago. The launch vehicle is sitting on its launch table and is towed by a truck from the final assembly building where the ATV was mated on the launch vehicle up to the launch pad some 4 kilometers away.
Takes about an hour to roll out there because the trucks, special trucks, roll out very slowly.
A very special truck indeed, capable of towing the equivalent of almost 3 Airbus A380 at full charge, but very low speed.
Can you give us a very quick explanation of the green status panels where everything is smooth?
So this, yes, this panel is the status of the different systems which are all involved in the synchronized sequence, and for which they have to be ready at the same time, at the same moment, to allow the launch.
And these include the launch base, the launcher, the satellites, in this case the ATV, Jules Verne, basically all the systems across this very big space base, Europe's spaceport. All these systems summarized by the green status panels coming into Jupiter here, which is why we call Jupiter the nerve center of the whole thing. The DDO, Thierry Vallée, again, you'll hear him call out the 1 minute mark in just a moment, and we'll be into the final 60 seconds.
À tous de DDO, attention pour moins 1 minute.
Are you going to go out and see the show?
I go and see the show.
Alex is going to step outside.
Top H0 moins 1 minute.
See you later. Alex is going out to the terrace. There are 2 terraces on either side of us here. The folks, the invited guests, are going out now. And he's going to watch the launch and come back, and he'll give us his impressions live. In the meantime, keep your eyes open for the final ignition sequence. You'll hear the DDO call out 3, 2, 1 ignition. And you'll see the main engine light up. And then count to 7, because during those 7 seconds, the computers that we've been talking about will be checking out pressure and temperature. And if they find everything all right, then they'll give the order to light the boosters. Those are the ones on the side there. And then we'll be off. So we'll let the DDO call out the final 10 seconds, and we'll let you enjoy the liftoff. And we'll be back with you after Ariane has cleared the tower.
À tous de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage Vulcain, allumage des EAP et décollage.
The night sky over Kourou here, always an impressive sight. 775 tons lifting off. The DDO is saying that everything is okay on board. Alex has just come rushing in. You look very pleased of what you've seen. How was it out there?
That was absolutely terrific. It was a marvelous show. The light and sound were absolutely impressive.
Paramètres bord normaux.
What impressed you most?
I think the sound, but it comes a little bit later, but the sound is really impressive.
That's not the first time you've seen a launch.
No, it's not the first time, but each time it's a little bit like the first time.
All right, sounds exciting. I'll go out next time.
So we are now in flight. So from now on, we shall leave the green panel and follow the launcher's health status on this little graphic that you can see
on the upper left
on the screen.
Now, what is that? That's the real trajectory and the optimum.
Yes, the curve represents a computed simulation of the whole trajectory. And the white spot on the curve represents the actual position of the launcher, which permanently sends a telemetry signal to the radars of the ground stations.
And on the bottom left, A and V on the bottom is altitude and...
Other indication of the velocity and altitude are real-time data.
Les paramètres bord sont normaux.
And also the angle between the launcher's antenna and the ground stations.
All right, we are into the first powered flight phase, which is the 2 boosters and the main engine. And you saw the lights before we lost Ariane to the cloud cover. The boosters will be burning for another 20 seconds or so.
The Vulcan engine will operate for about 8 minutes before it's shut down. And at this point, at an altitude of around 145 kilometers, the main stage will separate and follow our side ballistic trajectory before re-entering the atmosphere and fall down into the ocean.
Séparation des étages d'accélération à poudre.
There is the separation of the two solid boosters. This is what it looks like up there. The camera's not on board tonight. This is a camera shots from a flight last year, but you can see one of the boosters, both of them, one on the other side, dropping into the ocean, and then what happens?
Yeah, they are approximately 450 kilometers off the launch site of the coast of Kourou.
We're now into the second flight phase, the EPC, or the core stage. The core cryogenic stage is burning alone. It'll burn, as Alex said, for just under 10 minutes, pushing Ariane again across the Atlantic.
Well, a short time before the fairing separation.
Fairing separation will be next up. You'll hear the DDO call out that milestone. And the separation of the booster and the fairing, all done by more or less the same systems, am I right? Is pyrotechnic cords?
Absolutely, all the same systems, like the ones we used on Ariane 4.
Largage de la coiffe.
There the DDO has called out the separation of the fairing, and you'll get a shot of that.
We're on time.
Coming
and
up.
now
there's just one half of, actually there's two halves that are blown away into the fairing, and they also fall into the Atlantic. How much weight have we lost there?
We've lost about 2.5 tons, and the launcher has now lost approximately 70% of its total weight.
Remember, 775 tons at liftoff, and then we lose all the fuel in the boosters, and the fuel rapidly being burnt up in the core stage. You saw the launch site manager, Mr. Sikar, a moment ago. You can hear from him now on the launcher campaign. Take a look. The launch campaign for this flight, Flight 181, began at the end of last year and lasted throughout January. First, we integrated the two solid boosters and the main cryogenic stage. On this version, these stages are identical to those on an Ariane 5 ECA. In other words, with a Vulcan 2 engine on the cryogenic stage. The storable propellant upper stage was then mated, and it is on this stage and on the vehicle equipment bay that there are a number of specific adaptations. The vehicle equipment bay structure has been reinforced to cope with the mass of the ATV. Following integration, the launcher was transferred to the final assembly building. 2 days later, we began the combined operations plan for the two-phase ATV to launcher mating. The first phase concerned what we call the SDC, which is the launcher interface cylinder. And during the second phase, the ATV was integrated onto the mechanical interface.
Tous les soirs à 17h, nous avons une réunion d'avancement concernant les différentes opérations qui ont été effectuées durant cette journée. L'ensemble de l'équipe opérationnelle se réunit.
We hold status meetings at 5 p.m. every evening here in this room, where the entire team reviews the different operations that have been carried out that day and those scheduled for the next day.
Après différents contrôles,
following a number of checks, the fairing was integrated onto the ATV. Upon completion of the final preparations, we hold what we call the Launch Readiness Review. This is an important meeting at which authorization is given for the launcher to be rolled out to the launch zone. The different industries, the design authority, the technical authority, and the operational teams all attend this meeting, together with the Ariane Technical Committee. It is this Ariane Technical Committee that gives the green light for the launch vehicle to be rolled out to the launch zone.
Nous pouvons transférer le lanceur en zone de lancement.
On the launcher side, everything's fine. We have a good altitude and good velocity.
2 minutes left in the core stage, the EPC burn, extinction of the lower stage, due to come at about 8 minutes, exactly 8 minutes and 55 seconds. We're going to hear now from Philippe Roland. You can see him in the blue shirt there, the Ariane Space Mission Director on the ATV campaign.
The ATV spacecraft arrived in French Guiana in late July on board the Ariane spaceship. Its three separate parts had to be assembled gradually over the first 5 months of the campaign, from August to November. The spacecraft comprises the solar panels, shipped separately, the upper part of cargo, which after preparation will carry all the supplies for the ISS, and the lower part, which contains most of the propellant needed to reach the station. The ATV will modify the position of the ISS by roughly 80 kilometers, thus giving it around 3 years of autonomy. Between Christmas and the New Year, we began the ATV fueling operations, which lasted until late January. Final preparation started in mid-February. The thermal protection was installed and the satellite then transferred to the BAF, where it was mated onto the launcher and the fairing put in place. The flight will be relatively long, lasting more than 60 minutes before separation, and the launcher's behavior will be tracked by a network of stations. I would like to thank all of the international teams for their work on the ATV program over 7 months. It is thanks to them that Europe's spaceport will henceforth be seen as the departure point for the International Space Station.
A-OK on board. We're right where we should be. You saw during that film that we had acquisition of the ship downrange tracking station. Now we have a different trajectory tonight than we have for our normal standard GTO missions.
Yes, for a GTO mission we must get as close as possible to the equator plane, which usually means an orbit of 6 degrees or less inclination. Tonight we shall release the ATV.
The DDO has just called out the extinction of the lower stage, the separation of the lower stage, and we should be hearing him call out the ignition of the upper stage. And there it is. We've ignited the upper stage. Those 3 commands given by the onboard computer that's flying on the composite still with the ATV in about 12 seconds each. There's the lower stage being dropped back into the Atlantic.
Coming back to the orbits, we have an inclined 52 degrees orbit for the ATV. And from Kourou, we can perform launches to reach orbits with inclination from around 90 degrees for heliosynchronous orbits, then to 62 degrees for GTO orbits. As you can see, Kourou offers a wide variety of orbits and missions, including escape missions for interplanetary journeys, like we did for Rosetta.
We're into the upper stage burn now. Before we start focusing on the ATV in the second half of the mission, we just want to take a look at the role of tonight's version of the upper stage, the ES.
So the EPS, that was the perfect ignition of the upper stage for a first burn of approximately 8 minutes. This stage is made in Bremen by our German partners of EADS Astrium. Greetings to them. We might say that the EPS today has 2 missions. One, to provide necessary velocity to deliver the ATV on the proper orbit before separation, but secondly, to realize an atmospheric re-entry in order to free the low orbit region above the Earth, avoiding to remain as a particularly dangerous debris for other launchers or manned vehicles flying to the station.
The speed, as you can see, 7 kilometers per second on the lower left of your screen. The speed we need to separate the ATV is a little over 8.
Little over 8. We will not still there, but we are right on track. We are right on the prediction of the trajectory.
So keep your eyes on the speed there, and when you see 8 kilometers, you know we're approaching separation. We can start focusing on the ATV now. A series of films coming up. Here's the first from the European Space Agency on the ATV's role as a cargo ship.
In the years to come, the ATV will become one of the principal vehicles servicing the International Space Station with unprecedented capacities and capabilities. At over 19 tons, the heaviest payload ever placed under an Ariane fairing, the space truck is 10.3 meters long with a diameter of 4.5 meters. That's about the size of a London double-decker bus.